So basically, in talking to Matt over the past couple of weeks, I put together a presentation to basically go over a little bit of the past, kind of how did we get here. And so I'll talk a little bit about some of the issues that we've had to deal with displays over the years. And then I'll bring you through our monitors, the BVM-L230, and also some background on how we developed that product. So there are basically, one thing I do want to start off by saying is that the CRT is basically the last piece of our typical video system that we're finally getting around to completely replacing. What I mean by that is that if you think back, we're at least on our 5th generation on our cameras, right? We had basically Trinitron tubes, we had Vidicon tubes, Plumicon tubes. Back in the 80s, we finally shifted to CCD. And when it comes to VTRs, we go back to helical, Omega, and also 3/4 inch and Betacam, and of course all that was analog, and we finally shifted to digital sometime back in the 90s. So this has been a long time coming to transition completely away from CRT and to move to some other technology. So basically, what I thought I'd do is just take a minute and go back kind of to the beginning. I think as I look around here, I see at least a few of you guys that had to grow up with CRTs. I can't be the only one in the room that grew up in this business using a cathode ray tube. And early on, you may remember, there was basically one type of phosphor available. Right up until the mid-'80s, it was P22 phosphor. And I don't know if anybody can tell me, but does anybody remember where we consistently used that particular type of phosphor? Consumer TVs, right up to date. It was basically inexpensive, readily available, reliable, made nice images. The problem with P22 phosphor is that you couldn't match two monitors to make them look alike. So basically what that led SMPTE to do is to sometime, I want to say in the mid-'80s, we developed SMPTE and EBU phosphor, which was a very nice solution for us on the professional side of the business, because we could now finally match monitors and maintain our picture. The whole point here in selecting the correct monitor is to be able to maintain the same look from when we captured the image. And we need to think about purchasing a display device to maintain a continuity. The other issue that we can think about here is, for years, basically there was one format, NTSC, composite video. So you never thought to have to ask a customer or a vendor, manufacturer, does the camera output composite? Does your monitor take in composite? It was understood. That's all changed, as you well know. We have a lot of issues to deal with, including aspect ratio. It was basically 4:3 for years. We didn't have to make those considerations and consider that. So when you're buying a monitor or looking for a monitor, if you're transitioning, for example, from standard def to high def, these are legitimate considerations that you need to think about. Can you actually see a good sharp picture with a standard definition image as well as high def? Does it operate equally as well in both with both standards? And this is something that we work very hard on with our L230 to maintain quality regardless of what the source is. We didn't have issues to deal with component inputs or dealing with component signals, and of course we didn't have digital to deal with, and all that obviously has changed. So if we look back, and I say the past when I'm talking CRT, because as Matt mentioned, our PVM series, which was around for about 15 or 20 years, we stopped making that monitor in that entire series about 5 years ago. It'll be 5 years December that we stopped manufacturing that professional CRT display. And our broadcast side, we basically stopped making our 24 and 32 inch, which has pretty much been the standard for post-production or production for quite a few years now. So the only thing we're delivering at the moment is whatever we have left in stock for our 14 and 20 inch. So we are out of the CRT business. And one of the main reasons, by the way, that we dropped that business, which is a huge decision for us. We were a leader both on the consumer side and on the professional side. This was a very, very expensive and difficult decision for us to transition out of CRT. And one of the main reasons is 6, 7 years ago, we decided to completely bring our company up to the green standards. So in every respect now, in every product, we meet that criteria. As a matter of fact, we had to do without a closed caption in a couple of our products for about 3 or 4 years because we didn't have a chip that met that criteria. So what did we transition to? Well, we've been transitioning currently into LCD. And as a matter of fact, we had plasma displays for about the past 7 years, but we're on our last vintage or model offering in plasma. So probably within the next few months, we'll be totally on the professional side, a LCD company. Our consumer group dropped plasma about 2 or 3 years ago. So basically, LCD is our technology at this point. Some of the other technologies that are out and about is SXRD, which is a Sony version of LCOS. So basically for our high-end projectors, for example, and some of our consumer high-end projectors, we're offering that technology. It's a great technology. A DLP is a TI projector technology as well. And of course, our future technology that we're working with on the consumer side at the moment is OLED. We are delivering an 11-inch LED, OLED panel that sells for, sorry about that, I'm not supposed to give you prices here. I almost slipped into my sales mode here. But it's very affordable. And we're also $2,500. The field emission display is another technology that we've been working with as well over the past couple of years. So we have some other display possibilities coming, but for the moment, basically, and probably for the next 4 or 5 years, I would imagine at the very least, it will be LCD. So some of the differences, of course, we could talk for a couple of days in any detail with these different technologies, but just scraping the surface for the moment, some of the differences between the various display technologies is that CRT is an emissive technology, meaning that it develops its own backlight by an electron beam. And of course, the big benefit there, the major benefit, is that you can quickly turn the beam on and off, so that gives you nice rich blacks. So that's definitely what makes CRT, I think for most of us, kind of our benchmark is, does it perform as well as CRT? And I'm going to show you where LCD, through this presentation, will compete very well against LCD. LCD will compete very well against cathode ray tube. LCD, on the other hand, is a transmissive technology in that it does require a backlight. And some of my displays use a CCF backlight. My evaluation monitor uses an LED backlight. So it depends in what type of display you're looking for. If you're looking for a full evaluation tool, a true measuring device, then I have a monitor for that purpose. On the plasma side, again, it does operate and emulate in some ways CRT, in that it does develop its own backlight through UV. And so it does have some benefits in terms of improved black level. But I'm going to give you a quick comparison of these technologies in my next couple of slides. DLP and SXRD are reflective technologies, typically use either a UHP lamp as a backlight or a xenon lamp. So it depends on the price point and what the application is for that projector as well. And OLED and FED are both emissive technologies as well. So the fact that we're typically, if we're going to go out and make a decision, I think what I'm hearing most of my customers tell me is they're constantly, the fact that they know CRT, that they have a long track record using cathode ray tubes, they want to compare the performance of CRT versus LCD. So I put this a couple of slides together to give you an idea of where the two products are at. And one of the issues, and by the way, I have to remind you folks that CRT is plagued with problems. Just that we've had them for so long that we've kind of grown to knowing what the downsides are and the issues are. For example, geometric distortion, registration, issues with ambient light, the size of it, power consumption. So there's a lot of issues. Off-axis view was never that good with CRT. And basically you had two CRT technologies to choose from. It was either the shadow mask or the aperture grill. The aperture grill was the Sony, the shadow mask was the RCA. And basically one was cylindrical, the other was spherical. And they both had some benefits. But one thing that they both had issues with is they had this big, thick piece of glass in front of it. And anytime you operate a CRT with any amount of light at all, you do tend to wash the image out. So all that contrast that you feel that you gain by using CRT, you're adversely affected by the very room that you're using that display in. So what happens basically, if you look at my chart here, you basically have ambient light coming in through that thick glass, and it hits the phosphor, and it basically reflects back out. So it raises the black level. So you have to have a controlled environment to really appreciate the full capability of CRT, which most of your customers are not operating under those conditions when you're sitting in a typical home. If you look at LCD, the effects of ambient light, the fact that the filters polarize the light, it's non-issue unless it's a tremendous amount of light, typically not impacted by ambient light. So if you take a look at this up at my slide here, you can basically put any number there with CRT, because if you're operating under the right condition, it's going to be black. You turn the beam off or barely turn the beam on, and you're going to have a very, very black image. But as you bring brightness up, ambient light up rather, basically you can see what happens here. Your CRT starts to wash out. So this red zone here is great if you've got the perfect operating condition, which we seldom do. But LCD, on the other hand, it's going to give you a very, very consistent and constant, relatively good contrast ratio. And the other issue that we need to consider here is average picture level, APL. And what happens here, once again with CRT, if you ever have a chance, if you haven't had a chance, take an empty water glass and try to shine a flashlight through it. And you'll see that a good part of the light reflects back off the glass. And that's what's happening here. You've got, you have your information coming off your electron beam, and it reflects off the thick glass, back off the phosphor, so once again you're raising your black level. Now, I didn't have a CRT here tonight to prove my point, but I have done this in many instances where I simply demonstrate average picture level by just simply inputting a test signal, like a checkerboard test pattern. You bring white into a source and you suddenly start raising your black level, and this quickly raises very, very quickly. So your contrast ratio continues to drop, where your LCD is very, very consistent. And basically, right at the moment, actually, I have 0.2 nits here, but I actually have a improved operating software, which brings that down about another 30 or 40%. So my latest version software actually improves what I have up there at the moment in the L230. So comparisons to plasma. I think most customers right now are out there looking. There are no CRTs available. If there are some CRTs out there, there are far and few in between. So it really comes down to whether you're going to consider a plasma or a LCD display. So let's look at plasma initially. One is the fact that it's phosphor-based. You can burn it. You can burn a static image into a plasma display and not be able to rectify it unless you replace the panel. The other issue is reflection. The way a plasma panel is designed and made up, there's two glass planes, or two glass plates. So there is reflection issues. So again, unless you're operating under the right operating condition, you're going to have some adverse effects. The other issue here is if you're working in any high elevations, you've got this issue here, weakness to pressure. And there have been some advancements in this area that's improved that, but there are issues there, for sure. Not an issue with LCD. Vibration. If you lay it down to transport a plasma, good chance you break that glass plate. Not an issue for LCD. And total cost of ownership, power consumption is much greater. I have a bunch of charts that I could prove that point, but power consumption is definitely a consideration. If you consider you're typically never going to have one display, you're going to have many displays. And these days, with 16:9, you can't get away too often with a small program, a preview monitor. You need something fairly large because of the aspects. So it's going to be a lot more power consumption with plasma versus LCD. Some of the other considerations here, when we do a comparison, is that right at this point, plasma still offers a larger size than LCD, although Sharp showed 104-inch LCD during Infocom, and I believe they're shipping that product. So that's so there are large LCD displays and high-resolution displays on the LCD size as of this last month or two. A viewing angle is definitely improved on plasma. The fact that you don't have a filter on a plasma, you do have your off-axis is a wider cone than LCD. And we'll talk more about that as I go through my product. Response time and initial cost is generally less expensive. It's been around for a lot longer than LCD panels, so it's definitely less expensive. Although prices are dropping on LCD as well. Resolution is higher for LCD, so benefit. Brightness and contrast. The difference here is that in plasma, the brightness and contrast is dependent to a great degree on your source. So if you've got good source, you've got good contrast and brightness coming in, it's going to produce a fairly good brightness and contrast. It's very consistent here in LCD. It doesn't really change. Power consumption is much less, not likely to burn. There's no glass, so no reflection, so no issues or very little issue with ambient light. and no issues with pressure, and total cost of ownership, again, due to less power consumption, gives you, it's much lower. Your total cost of ownership is lower. Now, there's a number of different types of LCD technology. I was talking to somebody earlier, you, I guess, and of course, when you look at LCD displays, there's a whole broad variety of performance, and it depends on what type of scaler is in it, what type of source you're bringing into it, how high the resolution is, what type of panel technology. Is it a 10-bit panel? Is it an 8-bit panel? So these are all issues. And of course, the higher the performance, the higher the price. As the performance goes, the price goes. So we have basically settled in on this in-plane switching. And the reason why we have selected that for our professional monitors, my consumer group uses the PVA, vertical alignment type of technology. We needed to go with this technology because basically, even for screening or for production or post-production, you need to have obviously high performance and a fairly good off-axis view. And by us going to IPS, we're able to sit within a 15-degree cone for optimum performance. However, even off as much as 70%, it's still very, very good performance. But for the optimum performance is plus minus 15%, and that has to do with the type of panel that we selected for our professional displays. Another issue, of course, that we need to deal with when selecting or making a decision on display is what are you going to connect to it? You have to have a panel that's going to support the various sources that you need to view through this device. Another reason why to consider looking at a Sony professional display. Years ago, once again, it was simply NTSC, analog, no big deal, but that's not that way at all anymore. We support all of these old formats, but we also support all the newer and up and coming, SDI, HDSDI, DVI, HDCP, HDMI. We have those capabilities on our displays. So it's something to consider when you're selecting the correct display for your particular need. The other thing here is it's no longer just NTSC 358. Color spaces are all over the place these days. So if you're typically operating in NTSC now, you may be doing some type of post work for DCI, different color space. You may be doing something for EBU. In the past, you bought a monitor. If you were going to do something for Europe, EBU, you bought an EBU-based phosphor. And to do something in the States or Asia was typically SMPTE. Anybody know the difference between, in terms of look, between SMPTE and EBU? See any hands?
Well, one's a smaller color gamut slightly.
Yeah, one's it basically.
Slightly smaller.
Yeah, so one's a little warmer, one's slightly cooler. And I'll show you that on our Chromaticity Chart in a moment. So basically, you have to consider what type of color space you're going to be operating in. So the nice thing about going to LCD is that we have a matrix built in. So you simply, by menu selections, you can set your EBU. You can select SMPTE, DCI. There are 3 different levels of DCI. And also this XV color that consumer is pushing. So each one of these color spaces are broader. And one of the things we did with Backlight, we selected a backlight to support with a broad enough color space to support the various color gamuts that are out in the industry these days. So that brings me to my master series, and that is the Sony BVM-L230. I'd like to take you through a few slides here and see where this monitor fits in our offerings. So basically, if we take a look at my PowerPoint slide here, we have a grade 3, 2, and a grade 1 monitor. Our grade 1 monitors are basically our full evaluation monitor. And that's where the BVM-L series sits. It's our highest offering monitor at this point. And some of the things we guarantee you'll be able to do is use this as a measuring tool. And you can do that because basically we support all the various formats that are available in our industry to date. Okay. The other thing is the fact that we have used large-scale integrators that are very stable. So the components are stable, so you're going to guarantee to have the consistency and stability to know what you're looking at is true. So you're not always second-guessing yourself. Is it my source? Is it something in post? Or is it the display? This display is rock solid, so you're going to know that you're viewing, whatever you're viewing is exactly what is on your medium. We call this series our Trimaster series because we guarantee accurate color reproduction. And there are a number of reasons why we can make that claim. I'll tell you a little bit more about our backlight, our high purity LED backlight in a moment. For one thing, it uses its own 10-bit processor to maintain uniformity and also to maintain and create your white point. We're not using some of our processing power to accomplish that. It's separately, we have a separate processor just to maintain that in itself. We also have a precision imaging, and that's guaranteed by way of our high-res LCD panel, which is a 1920 by 1200 panel. Also, it's a full 10-bit panel. So we've got a 10-bit processor and a 10-bit panel. Most of our competitors are using an 8-bit processor or an 8-bit panel. And quality picture consistency has to do with the fact that, once again, our components are high-quality components, and the stability and consistency of reproducing an image is also guaranteed as well. So if we look here at my backlight, some information on our customized LCD panel is that when we selected the filters for this panel, we basically hand matched the backlight to the filters. So this is, again, this is a precise match between matching a backlight to the filters. It's a full RGB 10-bit driver. Its refresh rate is 120 hertz, so the motion artifacts that you typically will see in a lot of lower-end LCD panels, you won't see that with the Sony LCD. Precision backlight, superb uniformity, again, separate 10-bit processor, and our new display engine is a 12-bit, so you can bring a 444 source directly into this panel as well. So one of the few displays that you can take a 444 source and connect it directly into the L230. This is a block diagram. Of course, it's a lot more complicated than this, but just for the sake of this discussion, basically, what we did here, we spent, by the way, about 5 years developing this engine. And a lot of that came from customers like yourselves. We wanted to know basically what features in our A and D series that we needed to continue to support. And one of the main issues is uniformity. Okay, so when you look, regardless of where you look on the screen, you're always going to see the correct color temperature. And that's this, basically what we did here is this feedback circuit that we're looking at the backlight, and we're also sampling what's going on from our source. It's also looking at temperature and constantly correcting for any changes in temperature or any changes in our input signal. We have an excellent multi-scaler, IP conversion, color management, panel calibration. And one thing you'll notice with the L230, whether you bring in a high-def source, HD, SDI, or SDI, it's going to reproduce a phenomenal image. According to any of the customers I have demonstrated this to, and especially in the New York City area, they felt that it's one of the only panels that will reproduce standard def as well as high def. This is what the chromaticity chart can show us here, in that this is the various color spaces that we support. And if you look at this BVM-L native, that's basically the backlight of the LED. So that covers a full spectrum of color spaces that are out there. So it's not just NTSC, it's not just EBU. It takes you through a whole gamut of color spaces, including it supports the F23 and F35. So if you want to think about future-proofing your decision, this panel certainly gives you a long life in terms of its built-in capabilities that are already available. Little more information on the backlight. Basically, the way the backlight is set up on this panel is there are modules. There are 6 modules horizontally by 8 vertically. So in each module, we house our trios, our LED trios. So I believe it's about 24 trios. So it's red, green, red, blue, green, green, multiple greens for obvious reasons to maintain brightness. But it also has the RGB sensor, which is part of that feedback circuit I was just talking about a moment ago. So it's constantly looking at what's going on in terms of temperature and in terms of signal level as well, to maintain uniformity and maintain our white points. Another concern of our customer in this level display is basically latency. And basically you can see here with the 1080 60i source, you're at 11.9 milliseconds, so slightly more than a field is your typical audio delay. And as far as video latency in the picture itself, I've taken it into just about every high-end post house on the East Coast, and I haven't found a customer that could see any difference between their D or A series, BVM-A or D series, next to this. So that seems to be a non-issue in that regard. Now we know that even though it's 120 hertz refresh, there's still some artifacts, motion artifacts. So what we decided to do is add this black frame insertion. And the way this black frame insertion works is we lay down an active frame, lay down a black frame, lay down an active frame. So it basically takes the tails out. So for sports, for example, where you're apt to see motion artifacts, you turn this on. This can be turned on and off, and it can be saved as a shortcut, basically, on my controller. So that's one of the features that have been well received. And the other is for editing issues. If you're still doing a lot of 1080i editing, which I'm sure most of us are, you want to be able to identify an odd and an even field. And what this interlaced display mode does for us is it gives us the ability to lay down an active line, a black line, an active line, so you can identify your odd and even fields as you're going through your editing process. One of the few monitors, LCD displays that are on the market that gives you that capability. In terms of our presets, there's a DVI input that comes with the monitor, and basically these are all the VESA and SMPTE standards that we support. By the way, anytime you're using a plasma or an LCD panel, you connect a computer to it. If it doesn't work because it's out of range, first thing you want to go to is your lookup tables to see whether your computer is operating within those parameters. It's a basically we have 4 slots on the side of the L230, and you can install either HD SDI cards, SDI cards, component, analog component. There'll be a 3 gig card coming down the road that will support this at some point over the next, probably NAB, I would imagine. It's the fact that we don't have it by now. Probably we'll see it around NAB. And also we have a DVI Ethernet control. So with one controller through that Ethernet connection, you could control multiple displays. It also supports HDCP. So if you wanted to view a disk that's encoded, basically you can use this display to view it. This is just a comparison chart I put up to compare between our A24 and our L230. And you can see that we've added a lot of neat features. If you wanted to look at multiple images side by side, if you wanted to do butterfly, so you butt 2 images to see that they match, uncompressed, compressed. We also have blending, so if you wanted to look at your background and make sure it's keyed in correctly to your foreground, you can now do all that with my display. So the bottom line here is that it's not just full of features, but it's also, its specifications and its performance is built to support those features. So we didn't just load it with a lot of features, we also built it so that it would perform extremely well. Quick review, only monitor that matches to BVM CRT models. So this will match extremely well to the current CRT monitors. It has multi-standards, which I mentioned. It's a 10-bit, 120 hertz panel. It's a 12-bit processor, and displays the most accurate color gamut of any monitor on the market. Basically, is what we're seeing based on our tests that we've ran. It's not always 120 hertz refresh. It depends on the source. So if you come in with 24p, it's 96 hertz. And if you source at 50 hertz, it's sampling at 100. So it depends on what the source is, where the refresh will be. This is a question that comes up frequently in my travels with this display and back in my BVM-A and D series days, is what probe can I use to set it up? You shouldn't have to set this up too often, but I know a lot of customers, if you walk them in to a screening room, they want to see for themselves, how did you arrive at D65? How did you arrive at the color space you're operating in? Let me see. Well, these are the probes that will work with this monitor. Remember, the fact that it's LCD, you cannot use the grommet type probe and stick it on the face of the tube. You'll damage the LCD. So you've got to have it on a tripod. So keep that in mind. And I think that's my my presentation. Any questions?
I was just wondering if you knew why 16:10 aspect ratio for native seems out of HD is 16:9. Why?
Yeah, of panel availability, basically.
Repeat that for me.
That would be, the question is why did we select a 16:10 panel versus a 16:9? And yeah, that's a good question. Basically cost. Yeah. Yes?
The LEDs in the backlight are running in switched mode, correct?
Say that again?
The LEDs in the backlight are running in a switched mode. They're not on continuously.
No, that's correct, yeah.
Does that speed switch, does that change as you change, for example, say from 60 hertz to 120 hertz or something else? Are they also pulsing at a faster rate or a
No,
lower rate, or is it constant?
I'm not sure if No, I don't think the refresh changes there. What that's going to, when that's going to change, when that's going to be impacted is when you are changing your white points or your color space, typically, or if something changes drastically in your input source, you'll get some change. But the biggest change there is the color space you're using or the white point that you selected.
Well, the switched LEDs appear to fool some colorimeters as far as measuring gamma. They tend to measure it as undersaturated.
Yeah, yeah, that is true.
Because they can't keep up with the switching speed of the LEDs.
Of the LEDs, yeah.
So you have a correction for that if you're using other software.
Yeah, absolutely. Any other questions? Okay, thank you very much for your time. I appreciate it.